I want to learn fencing so bad. I've looked everywhere, only if I could find a good fencing classes. I should keep on searching on the web.
Hey, welcome to fencing class. Today we're gonna learn how to lunge. Do this. Do this. No, that's terrible. Lower your arm. Yo, lower your arm. No, and it's higher, higher, higher. Oh, no. Lunge properly. Lunge properly. Bend your knee more. Bend your knee more. Not that much. That's too much. Oh my God, you're awful. Go home. You're never gonna be able to fence.
Hi, we are Team 19 Blade Trackers, presenting assignment 3 for deep learning and convolutional neural networks. For our project, we built a web app designed for helping fencing athletes improve their technique through AI. Fencing is a very technical sport that relies on precision, posture, and most of all timing. Traditionally, learning fencing requires in-person coaching, which can cost around $40 for just a 45-minute session. And that's not even considering travel time, scheduling issues, and access to qualified coaches. We wanted to see if we could use deep learning and computer vision to make high-quality fencing training more affordable, accessible, and flexible for students.
Fencing training is expensive and not always accessible. Many students who want to learn or improve simply can't afford regular coaching sessions. And even when you can afford it, real-time feedback is limited to the short time you have with your coach. There's often no way to track progress in your own time. Communication barriers such as language often get in the way of good training, and coaches even make mistakes, meaning feedback can be unreliable. That's why we created a tool that provides automated feedback using deep learning. Introducing Lunge and Learn. It helps fencers evaluate their form, classify poses, and understand where they are in their technique without needing a coach present.
Now we'll show you how the app works. First, we see this user-friendly UI meticulously designed and wireframed. Users can explore our blog. They can learn about our mission statement, and they can contact us. To use the app, users first have to log on. Then select your dominant hand. Users can choose to upload a video live or record a fencing video. Cropping the video is extremely important to make sure the correct movement is analyzed. Cropping can be done by both changing the video size and the start and end times. Finally, we click Upload. While the screen is loading, many things are happening. The app detects and crops out just the fencer. Then we extract pose key points. The key points are processed by removing empty frames, interpolating missing data, and computing angles. Then the clip is fed into our model to classify the type of fencing pose for each 1 second window in the clip.
Here are the results of the classification. We can see the LSTM has identified the pose as a flesh with 100% confidence. Our app compares individual frames to ideal reference poses and highlights which body angles change and by how much over time, giving users a breakdown of their form. Correct angles are given by green and incorrect angles are given by red. We wrote an algorithm that runs a sliding window over longer clips and generates a graph of pose over time. This helps athletes see how their form changes throughout a move. In this case, the athlete retained a flesh throughout the entire movement. Finally, an LLM takes the output of the LSTM and recommends some strategies to improve.